Hi there, and welcome to The InEVitable. This is MotorTrend's podcast about the future of mobility, the future of the car, where we're going, how we're going to get there. And new, this vodcast is brought to you by the all-electric Nissan Ariya, inspired by the future, designed for the now.
And that's great. My name is Ed Lowe. I'm the head of editorial at MotorTrend, and you just heard our very first sponsor, Reed.
Yeah.
Because we have all sorts of new stuff going on this year. You saw it in the intro. We have a new sponsor.
Thank you, Nissan.
Thank you, Nissan. Thank you, Nissan Ariya.
Do we get free GTR? Anyways.
Yes, that's what I
Nissan.
alluded to in changing up the graphics. But this is going to be great. We're very excited to welcome our new sponsor. You're going to hear that Reed quite a bit going forward. And we have some new features in the podcast. We are going to give away some swag. We'll tell you about it in a little bit.
We'll give this cup. Look at this. We got hats.
We'll tell you about in a little bit how we're going to do that.
I'll mail you Ed's shoes if you want.
Yes.
But you got to do some stuff for us, and we'll get to that.
Yes, we'll get to that. And we are, we want you guys to be invested in this, so we're going to answer some of your questions more directly. Whenever we go live.
Is this our new segment, Question of the Week?
Question of the Week. You've been dropping us questions on our Instagram. You occasionally drop questions in our YouTube channel. Keep doing that. Let us know. Send us your questions. And we have one, actually. We seeded the field a little bit, and our pal, Dr. Bobby Bones, Bob Cho, who's actually the chief of staff at the Shriners Children's Los Angeles
Like the most impressive,
human on
magnanimous
earth.
person I know. I actually feel like just guilty for being such a horrible man whenever I'm near him. But
yes, Bob Cho asked us a question.
And a GTR.
Yes, he's a former GTR.
Which has nothing to do with the Nissan thing, but he.
Yes. Anyways, Bob Cho asked us a question. When do you think we will go to a single charging standard? VW doesn't seem to want to give up the CCS plug, and I've seen more broken Electrify America stations than working ones. So it's a great question, as a lot of people know, and we've covered this on MotorTrend.
But we could also do an entire show just on this question.
Yes.
But to keep it brief, Volkswagen announced, since Bob asked that question, that them, Audi, and Scout, the upcoming all-electric truck and SUV brand from Volkswagen, they're going to NACS, the Tesla Charging Standard.
It's called North American Charging Standard.
Yeah.
And over a dozen manufacturers have decided to abandon the CCS plug, the SAE CCS plug. The round one, if you guys know what we're talking about, that looks kind of like a ray gun, and it's got a little clip on the top, in favor of Tesla's North American Charging Standard, which has no moving parts. It's slimmer. It's generally considered to be the gold standard for charging, at least in North America. To his question, when do we think we will all get there? That's a good question. There are some limitations to NACS, as we understand it. They're not as fast or as high output as the top end of CCS.
So CCS, in theory, can go up to 350 kilowatts into the vehicle, although you never really see that. Right. But NACS, there is a new one that's coming for the Cybertruck, and I saw some new stations installed. Yeah. So when? 2027, I think, is a good guess when you'll stop seeing a lot of CCS stuff sold. But it's weird because, currently at my house, and I drive a lot of different cars, I have a CCS charger for my truck. And I've been thinking, boy, I'm going to start getting press cars that are, I won't be able to charge at home. And it kind of makes EVs terrible if you can't charge them at home. So when I put in the charger, I actually had 2 wires drop because I wanted to put in 2 chargers eventually because I figured one day I'd own 2 EVs. But now what I think I'm going to do is an NACS charger and a CCS charger and keep it that way until it all converts over to NACS.
Yeah, there's a lot. So what Johnny's talking about is probably level. So it's higher level thinking. You're going to see a lot of this transition happening basically now.
That's the nicest thing you've ever said about me, Ed.
Hang on. All the OEMs, Ford led the way with the announcement of going to North American Charging System, NACS. GM has followed suit. It's all happening literally right now. February, March is when they start to roll out these adapters that allow you to use an NACS charger, one of the Tesla chargers, with your current F-150 Lightning or Mustang Mach-E. Basically, in the next 12 to 18 months, all these car companies are going to get this thing sorted. Will everybody be on one single charging standard? I don't think so.
But this is just VHS Betamax 2024 edition.
We'll see.
The one's winning out. And again, the other thing, I think it's such a big thing, we should probably devote an entire show to it, but the alliance of GM, Stellantis. And remember, Stellantis is much bigger than we think it is in the U.S., and they're making a lot of moves, as you'll find out in a second with our CES guests. Volvo, BMW, Hyundai, Kia, Genesis, and I think there's one more, but they're building a competitor to the Tesla supercharger network.
Right.
And Tesla right now, I think they're like 18,000.
22,000.
Oh, they added a lot more. 22,000 chargers in North America. So? Yeah, it's either 17, 18, or 22. But this alliance is going to be like 30,000 chargers. So once that happens, and that should be happening real soon, just game on for EVs. It's going to be a big change.
Good question. We want to encourage that. So please ask us more questions. You can shoot them to Johnny and I directly in our Instagram. So I'm at Lowdown, LOHDOWN. It's at Johnny Lieberman.
Yeah, just Google me.
Or drop them in the YouTube comments. Yeah. So just send us a question and we'll pick it.
We're too lazy to make an InEVitable email. So if you write to MotorTrend@MotorTrend.com, we will get your question that way. And if it's a good question, maybe we'll send you something like this.
Send you some swag. Send you a T-shirt. Belt buckle. You name it. Okay.
All right.
So we covered it off. We got a new sponsor. We got some new segments. We got some new audiovisual stuff. And we have some great conversations about the future of mobility coming live and direct from CES. So Johnny and I went to CES, which used to be called the Consumer Electronics Show, but actually apparently doesn't mean anything anymore. But it's all about tech. No, CES is not an acronym aninimore.
No, I know. It's funny. It doesn't mean anything anymore, but it's the biggest trade show there is.
Biggest trade show in tech in the world, arguably in the world, happened in Vegas just about a month ago. Yeah. So these are all pretty hot and fresh. And we did something different here. Everybody's super busy. It was hard to get this caliber of expert, executive PhDs, professors, and this and that.
For our normal 2-hour deep dive interview, right. Tell us everything about yourself. So we did a series of like 30 to 45-minute interviews, and we're bundling them together. Today you get 2.
Exactly.
And we're starting off with...
for Fabrizio Martini.
A person who's much smarter than me and Ed, who, he was sending stuff to Venus, and now he has his own battery consultancy company.
Yes, so Fabrizio Martini of Electra Vehicles. We'll be chatting with him. And then we're going to follow up with a guy, Professor Shai Shalev-Shwartz from Mobileye. So we'll go first.
Yeah, start with Martini.
With Martini,
like
always.
Dinner, right?
Start with the Martini. And then you'll get a chance to hear from the
Professor
Schwartz of Mobileye. All right, so welcome, Fabrizio Martini, right? Did I get it right?
Good
me?
name.
Yeah.
Fabrizio Martini sounds made up.
It does.
That's
it actually,
really good.
You sound like it sounds like a cartoon character's name from a Pixar movie.
Yeah, I was going to say the bad guy in Cars 4, yeah.
It's easy to introduce myself because people pick up my last name very easily.
Mr. Martini.
Mr. Martini.
Yeah, like the drink.
Do you like martinis?
I do like martinis,
yes. Whoa. Gin or vodka?
I think the traditional one.
It's gin.
Gin.
Yes. Okay, great.
Ed,
you can stay.
if people knew more about us, you and I should not be talking about martinis at all.
Yes, we should.
So on that
note, drink and drive.
Exactly.
Unless the car drives itself. On that note, so
Electra Vehicles.
Yeah. Tell us everything.
Yeah,
as far as I know, you guys are like, if I'm gonna build a new battery, I use your services to help me optimize my battery. Is that?
We can help with that. We can help with the design of new battery packs, new architectures. We can help with the analytics. We have a predictive analytics tool, and we have an advanced control strategy that we call EVI. The project started from a NASA project. I was a principal investigator working for the exploration of Venus. We are trying to explore the surface of Venus, and they need an electric rover. So they wanted to see which batteries could actually be deployed on Venus, and they wanted to be able to predict failure up to 1 year in advance. So any thermal runaways, any potential explosion issues with prediction.
And Venus is tricky because the surface temperature is like 800 degrees Fahrenheit, right? It's extremely hot.
It goes very low and very high.
It does go low.
It does go low, yeah, absolutely.
When it's not facing the sun.
Okay.
Because Venus is second planet from the sun, but it's the hottest
big fat atmosphere. Yeah,
it's hotter than Mercury.
Yeah.
Because Mercury has an atmosphere.
Yeah.
Venus basically does not.
Correct. So it was very challenging, but we were able to explore battery manufacture all over the world, from North America, Europe, China, South Korea, many other areas. But what we have seen is that the software stack what was really making a big difference from the hardware. So whatever battery we were picking, the software was making a big difference. Was increasing energy density, that means more mileage. It was increasing the power, that means more horsepower. And also we were able to predict failure, not 12 months in advance like the NASA folks wanted, but up to 3 months in advance we can predict any failures of any chemistries.
Okay,
let's start with that.
Hey, let's start. This is crazy. So you're the principal investigator on a NASA project of exploring Venus in an electric rover.
Correct.
What was the name of the project?
It's still ongoing. It's a Venus exploration project.
Okay.
Although lately Mars and lately the Moon exploration, we want to send the first woman to the Moon by 2026. So it's upcoming for sure. So that Venus program has started to place a bit less relevant, but it's still there. There are still developers working on it. A great relationship with NASA.
Plus, I think Russia's going to Venus, right?
Everybody's going everywhere. In
Yeah.
So how long are you at NASA?
2 years.
2 years?
Yeah.
And what's your background? Are you a PhD?
I did a master and I started a PhD at Northeastern University.
Okay.
I'm originally from Italy, where I did yes, you cannot say it, right? It's a little Italian accent. So I'm originally from Italy. I moved to the United States about 15 years ago, and I did a master and I started a PhD at Northeastern University in Boston.
In what field?
The bachelor was in vehicles dynamics. And then when I moved to US, it was 2008, 2009. It was a big push in electrification and batteries development. The USA government invested $500 million plus.
That was the end of the Obama administration.
Exactly,
you
got it. So I was lucky enough to start to work for the Department of Energy first, Department of Defense after, and then NASA for the last 2 years.
Oh, okay.
And then when I decided to transfer the software stack to a private business called Electra Vehicles, and we started about 6-7 years ago. And now we are a team of 55 people. We have great partners like BlackBerry, Stellantis, and many others. And we are bringing innovation for the design, analytics, and controls of battery packs.
So, there's a lot of, let's say, mental barriers to Americans specifically buying new electric vehicles, and I call it FUD, just fear, uncertainty, doubt. And one of them is like fires, but like
thermal runaway.
But I think going with that, is being able to predict failure. Like how do you do that? What are the markers you look for?
Machine learning and artificial intelligence. Those are keywords that can help us with ChatGPT, great, but can also help us to predict failure. We have demonstrated with the Californian companies that we are able to predict 5 out of 5 failures of a set of 55 vehicles. We are able to predict up to 3 months in advance potential thermal runaways or so on, thanks to machine learning. And data.
So in other words, there's a bunch of variables, and the machine says when X, Y, and Z happen, 3 months from now, something bad goes with the battery, and so you can predictively say, is that basically it?
Correct. So our algorithm, we call what the innovation is called the EVI. It's a brain for batteries. It's a very advanced software that leverages a lot of data coming out from the battery, the vehicle, the driver, and the environment. It's a 360 degrees data inputs. In our patents, we have over 130 inputs. Of course, the main one are voltage, current, and temperature, as everybody knows, but there are way more related to the driver. How do you drive your vehicle? Are you an aggressive driver or not, and so on? Where do you drive the vehicle? Is it in Boston, in Palo Alto, in Milan, Italy, or in Seoul, Korea, and so on?
So in other words, environmental factors play in, heat and humidity and whatever.
How you charge the vehicle? Are you doing a lot of fast charge that could damage the battery heavily? Are you doing a lot of high acceleration that could damage the battery? The machine learning capture all of these instances, and then we leverage a digital twin of the battery in the cloud. We are partnered with AWS, and we create a digital twin of the battery.
That's
an
wild.
exact replica. But the way we do it at Electra, we do it differently. We do physics-based model plus a data-driven model, and we combine the two. The industry a few years ago moved all to physics-based, and then a couple of years ago moved all to data-driven. The solution is both combined.
This is crazy.
That's
this
cool.
Is wild.
I like the virtual battery in the cloud.
So you have...
And real quick, though, you can do an infinite number of those. Like for every vehicle with a battery, you can have its virtual clone in the cloud and be monitoring the battery.
And custom. You can have your own digital twin of your own battery pack. You can have your own head, and I can have my own as well. So each individual, we can start from the same battery pack. We can all buy from the same vendor, same model. But then the algorithm becomes unique. So you, driver, have your own singular digital twin of your batteries.
Yeah.
Wow.
Johnny loves to rapidly discharge his batteries all day long because he's like a super lead foot, and then I'm way more cautious. Okay, wait, but hold on, that's a lot. I'm trying to keep. I'm barely holding on, so I know our audience is probably like, what are they talking about? So you're talking from a data-driven perspective. You're talking about all the variables in your data set. This is time, voltage, time, temperature, location, like hundreds of potential variables, right? Thousands?
Well, the data inputs are about 100, 130, and so on.
Okay.
And then the uniqueness are infinite, because you can have infinite current, temperature, voltages, and so on.
And that's where machine learning comes in, because you need a brute force approach from a machine that can basically see all of these changes in this data set and then make a prediction. Okay.
Absolutely.
So, all right, so that's accurate. That's the data portion. What's the physics model?
Physics model is basically the idea of you take a battery, and then you do a full set of experiments under a design of experiments. So you fully characterize the battery by discharge curves at different current, at different temperature. So you have an exact replica of the physical object in digital.
Right.
Oh, okay. So, but an actual physical test on a physical model, requiring a lab, and
correct. We have a couple of partners.
They're like Lucid has like a battery research place at their headquarters, and they use like these. They kind of look like ovens.
Sure.
And you put a battery cell in there.
Yeah.
Run electricity through it at you put in like a race, because they do like Formula E. Yeah. So like here's what the throttle will look like through the race. Change the humidity, change the temperature, change the salt, same kind of
That's
testing?
exactly it. So you want to produce as many scenarios as possible, but physics-based model cannot cover all the scenarios.
Yeah.
The machine learning and data-driven can, because the machine learning start to improve while you take off, you go to work, you go to the gym, you go to pick up your kids, start to learn more and more. That's why at Electra, we have developed digital twin of batteries of multiple chemistries, whether it's NMC, LFP, LTO, lithium metal, solid state, digital twin of those batteries based on physics-based and machine learning. And that's extremely powerful, because it can give a big advantage to the driver and the user experience.
Can we pause right there and talk about like the current state of automotive battery tech? Like, everybody lithium ion, but now everyone's moving to lithium ion phosphate.
Let's do that one second, because I actually have a question about what he was saying about. So just so I understand it, the physics based model sounds, I mean, I get it, and it's old school, because you're actually using the experiment, but it sounds really expensive, right? Is that, I mean, from a cost perspective, right? If you have a good data-driven model, machine learning model, you can do infinite number of tests, and without needing a lab, needing physical experiments. So why then do you need why is it better for you to combine the two?
Just got to make sure it lines up with
very
reality.
Good question. So the industry actually initially had the focus only on physics-based model, and then they realized what you just mentioned, that was extremely expensive. So then they move to data-driven model, and they say, okay, let's collect as much data as possible. But what they were missing is that the physics-based give you a full understanding of the basic principle on how the chemistry works in different scenarios, and you cannot really cover those with machine learning, because sometimes you don't experience a certain temperature, you don't experience certain current, you don't experience certain scenarios. So it's like a map, and in the map you start to cover areas with a physics base, but then you start to see some spots, and those spots are being covered by machine learning. So the combo is really nice. And when you apply machine learning, you don't have to do thousands of physical-based tests that we're going to spend millions of dollars and so on. You can run the set of tests. Electra has a design of experiments specific for each chemistry. You run through those, and you have enough data to have your basic physics-based model. And then machine learning can be from day one, when you buy the vehicle, to end of life.
Okay. So now, and then before we get to this, here's a good question on battery, the state of battery tech, but now I get it. So your shirt, we were talking about before we went on this sleeve, you have your partners, right?
Yeah, proud partners.
So you're proud partners. So you got AWS.
Thank you, sponsors.
Is that Qualcomm, I see?
Qualcomm,
Texas Instruments, NXP,
Stellantis.
and Stellantis. So
BlackBerry.
BlackBerry, yes. Whose booth we're in? Thank you, BlackBerry.
Yes.
I get why a company like Stellantis, even though everyone's trying to go vertical, they're not going to want to do what you're doing, because this is highly specialized, right? Or at some point, is it, and maybe I'm jumping to the end, is like, are you waiting to be acquired as like a big company to buy out what you do, or?
So the reason why it's extremely important for OEMs to work a technology provider like the Electra vehicles is because we have been training our algorithm and neural nets for the last 6-7 years with not only a specific brand and model, but multiple brands. We work with the two-wheelers, three-wheelers, passenger cars, trucks, delivery trucks, and more, and so on.
Buses,
Drones, buses, and so on.
Yeah.
So the network effect is something that you cannot buy time with the network effect. You need to run the algorithm over and over. So when a company like Stellantis or other are interested into this, they want to jumpstart the competition, and instead of start building data set and training algorithm that will take 2, 3, 5, 10 years,
they partner with
they
you
partner
because
with
you
us,
have all the data.
and they immediately have solution after a couple of weeks of data inputs. They have beautiful output, and we should talk about which are the output, because maybe this is what the people are interested in.
So you just buy everybody's battery and start building, testing?
Electra has characterized over 330 batteries from over 80 manufacturers in the world. So we have done the first 3-4 years of the company, we have characterized most of the batteries around the world. And of course, lately we have been working with the enriched NMC chemistry, lithium metal, some solid state, to continue to build up that battery database. But we have over 330 batteries fully modeled.
Yeah, I was gonna say, it's fast because when I was looking at Lucid's battery testing department, I mean, they just literally had battery cells from Sony. In fact, the Lucid Air, my understanding is that they were, I think it was Sony, and they said, we want to use this, and they said, no, we didn't design that for automotive. And Lucid said, this is the perfect battery for us. And they said, all right, but you got to take the word Sony off of it. We'll sell it to you wholesale undercover.
I'm sure they're really happy that you're telling everybody.
Whatever. And then Sony was like, could you put the name back on? And they're like, no.
So then do you...
But it's fascinating because it's just batteries.
But dumb question. Do you buy these batteries, just go out to the manufacturer, or do they want to give them to you? I mean, you're creating a deep database that you might eventually sell back to them using their technology, right? Or
exactly, you're right. So yes, we do batteries. We receive the batteries from our partners. We receive batteries from OEMs and a mix of those. And we have 2 laboratories, 2 partners, one in Italy, one in North America, to run all the tests for us. Because we are a software company. We are a pure software, so we license our algorithm.
So in other words, what you're saying, like, let's say, just pick on Sony again. Brand X makes a car with a bunch of Sony batteries in a pack, and so does brand Y, but it's like different configuration. So in other words, like, they both might be the same brand of battery, but because of the way they're put together, different voltages, it might different results.
It changes performance for sure. The architecture changes performance. Electra has developed a solution called N-Power that helps also to design the next generation batteries. So we work with a couple of battery manufacturers saying exactly this. We love these kind of specs. Help us to build that. And what we do, we leverage machine learning and AI to, instead of running thousands of tests, we actually run a few tens of tests and simulate most of the others. So ML can also help us to cut down 98% of R&D time. So instead of 10 years of development, we do it in 6 months, 1 year, 1.5 year maximum of developing new chemistries. We must leverage machine learning and AI as much as possible. Great for ChatGPT, but can be deployed for electric vehicles.
So then you must have pretty good competitive. Do partners reach out for competitive analysis? Yes, okay.
But Electra started very early. If you look at our competitors, Electra was one of the first ones to start 6-7 years ago. That was also supported by USA government that invested a lot of money back in 2010 and also in 2017-18 into electrification and battery development. And so we have a competitive advantage of that time to market.
Your first packs must have been Tesla and the Panasonic packs and Nissan Leafs and that and stuff?
Initially, we actually had the Tesla Model S in 2017-18. We ran a lot of tests in Arizona, many areas to collect data. But then we started to add Stellantis Fiat 500, the Hyundai Kona, Hyundai Ioniq 5, and many other vehicles to collect data. We actually have drivers right now that while we have in this chart, they are driving and collecting data for us. So we have a network of battery testing facilities and drivers that collect data for us and feed all in this case, AWS Cloud to feed the data lake.
Interesting. Data lake.
So, but I do want to talk about the state of automotive battery tech. Like, where are we at?
We're in Vegas, okay? If you're going to put a bet on battery chemistry, and we want it to hit, what's the one? What do you believe in?
There is not going to be one. There are going to be several.
Give me your top three. The trifecta.
They're continue to develop. We are just at the beginning of battery development.
Right.
But definitely NMC, LFP, and the next one would be lithium metal. So I think these three. There is also sodium ion quite picking up due to cost and safety. But NMC and LFP will be the biggest one, and then the other will start to come up more and more.
What about, we had a guy on the podcast from Our Next Energy. They are doing the dual chemistry battery. They call it, I think, Gemini.
Gemini, yeah. One for acceleration, one for steady state.
Good idea, bad idea?
So in the NASA project, the design was actually 3 batteries working together because of the temperature range that you were mentioning, Johnny. Is that what we have developed there, Electra has developed an algorithm that can power split. So leverage 2 or 3 chemistries. And what we have showcased is that combining 2 chemistries with the NML algorithm, so instead of having a switch on-off, so one battery or the other, we have developed an algorithm that utilizes both batteries as needed and mix and match the two. We actually have demonstrated on a small battery pack. We didn't do a large in-vehicle demo, but we have algorithm that we license to OEMs to run 2 batteries. So that's another aspect. Because I mentioned to you, design, analytics, and controls. Under the controls umbrella, there is smart charging we can talk about, but there is also power split of 2 chemistries. So we can we could collaborate with them.
So you mentioned briefly solid state batteries, and Toyota's made a big promise that they're coming in 2025. Where's this technology at? And for people listening, like what's the real advantage of a solid state battery?
Do you believe that we're going to see solid state in that time frame, or is it?
No, it's going to be very challenging.
Why?
So one of our, it's the manufacturing issues, but one of our technical advisor, Dr. Claudio Capiglia, is one of the inventor of the solid state technology at Toyota 20 years ago, 25 years ago. And there are a lot of limitations on full solid state batteries, in particular on the manufacturing aspect. The ceramic layer that you need to put between anode and cathode, it's very easy to build at a laboratory scale or a pilot scale, but when you start to do mass production, it's very hard at the edges. They can break, they can have edges problem and so on. This problem has not been solved yet on the science aspect. So it's not an engineering optimization, it's science, and it's not been resolved yet. So it will take time. But there are other chemistry like enriched NMC or lithium metal that are picking up way faster. But they need a software layer, like the one we provide, in order to make sure that to predict failure, because those batteries can fail rapidly.
More rapidly than lithium ion?
Yeah, because they're pushed to the limits.
And you said lithium metal was one?
Yeah, lithium metal.
So describe that. What is a lithium metal battery?
It's one of the 2 electrode is a pure metal foil.
Made of?
Lithium.
The
lithium foil.
Also solid lithium.
Yeah.
Okay.
And that's somewhat
increased energy density and mileage.
And advantageous for us in the U.S. as we are rapidly behind China, and China has locked down all of the resources for battery production. But we've discovered...
Yeah, America is nothing but lithium.
Yeah, apparently
the whole country is made of lithium.
The whole country is made of lithium. So
right?
maybe that provides a little bit of a strategic advantage for us as we're building up our battery.
But I'm still convinced, definitely the material challenge will be definitely a global things to discuss and so on. Yeah. But I still believe that the software stack, MLAI stack, is what makes it a big difference. That's why I put all my saving, all my life, everything, and the team as well into Electra.
Let's talk about that. So I still have no idea what. So your degree is? Are you a computer scientist? Are you a coder? What are your degrees in? Like
my
NASA
degrees is in mechanical engineering. But I have a great team of PhDs, over 37 PhDs. Helping me. They are great minds. Okay. The team is what really making a difference. And we are a full remote company. So we have people from all over North America and all over Europe. And those people are very talented. They can go to work for Meta, can go to work for Tesla, AWS. And the reason why they work for Electra, there are two. One is because they believe in the mission and vision and values we have. We have a very long-term vision on how software-defined vehicles can really make a big paradigm shift to the inevitable EV race.
Look at
but
this
also
guy.
because
they hire this
Good.
guy.
Pro.
they
He's good.
by great name, by the way. It will be inevitable. But also the reason that
Ed needs
working
constant validation.
Thank you. Thank you.
absolutely,
Yeah.
years said. But the fact that they can work remotely, they love that because we have people from Atlanta, Chicago, Spain, Portugal, Italy, anywhere in the world, and they love that flexibility. So
I'm still blown away because this is so funny. Right now in this shift from electromechanical vehicles to software-defined vehicles, it seems like everybody, they're all mechanical engineers that are founding these companies. So yeah, like, well, when I went to school, like, I didn't really want to study CS or electrical engineering. How much of your day is immersed in code? In that side of it, like, you had to learn all this stuff. Like, I mean, at NASA, you went to NASA as a mechanical engineer specializing in batteries? Hypercapacitors is what I heard. Ultracapacitors.
Good job. Yeah, supercapacitor was definitely one of the chemistries where we're deploying for the high power stack. To
Also
give you
yes, but also not mechanical engineering. Like, where did you pick up all this physics?
No, the master and PhD was on basically material science and chemistry.
Got it. Okay.
Yeah, but then we are seeing that every time we add in a software stack, we are improving the performance. So you had like an energy density, and then with software you're able to increase 10, 15, 20% extra energy. So you're able to squeeze more energy out. Fast charge a battery thanks to software stack can also happen. So the software makes a big difference. And then I started to hire great minds that are in the team that are all like ML/AI experts, data scientists, and so on. Okay. We are mainly driven by that.
Okay, this is fascinating because. Again, he said it. He said it not twice. Let me break it down for you because it's something I'm barely holding on to. Through all of your testing, virtual machine learning in the cloud to physical testing, you're able to analyze all these batteries, and basically say that if you have a battery of a certain potential, the software that manages it on top of it can provide. A measurable, a substantial advantage if it's well written, if it's well executed. And I think this is the challenge of the industry where there's not a lot of people who understand software at that level where they can execute and take advantage of this potential.
Absolutely. Before you mentioned about what you're planning, you consider to be acquired, Electra has received 6 offers for acquisitions because for a couple of reasons. One, we have a great team of talents. The other ones, we have over 8 patents around what I'm sharing and claiming here. And then we have a trained machine learning model for the last 6-7 years and so on. And the number of data points started to grow more and more. We reached 1.2 billion data points in our algorithm in the data lakes that we are talking about. So the power of this machine is becoming extremely strong. And we are looking for partners like Stellantis and others, OEMs, to deploy this to the mass market. Because think about billions of electric vehicles in a couple of years, but millions of electric vehicles all connected to the same couple of battery digital twin. What could happen? Your battery pack and your vehicle will improve performance. Your vehicle can learn if it's going to catch fire or not in a couple of weeks or a month or so. This is extremely important. So we want to deploy this to market.
How do I put this? You could do anything with this is battery control software. So I was talking, I can't remember the company's name. It's like something humanity, but like basically, there's a problem where windmills are great. They create terawatts of electricity, and if there's nowhere for it to go, it's gone. They generate it and just goes away. So some like Germany, they're starting to like turn it into hydrogen. But this other company was saying, hey, if everybody plugs their electric cars in at night, put the energy there. We'll pay you like a little bit of money to store our energy temporarily, and then in the middle of the night it'll go out, and then you'll draw in more energy. And so but you can control for that kind of thing, right?
Absolutely. So we are exploring the V2X integration. So when you connect your vehicle to your house, for example, and you start exchange energy. The problem is that by doing so, you're gonna wear the battery, but the question is by how much.
Right.
So, and what we do as a company, we provide a very accurate state of health degradation.
There you go. Okay.
So we basically tell you in every instance how much value is left in your battery. And that's extremely important. We create a certificate of health that you can click at any time and say, oh, my battery is at 83%, and this is the value, $26,000 and so on.
And this is going to also become more important, not only for electric car adoption, but people are going to get batteries for their homes, and you can analyze the battery in your house, and you'll know, go to sell a house, this is what the battery's worth, this is how much life is left in it. Also,
to resell the batteries, or sell the vehicles. Right now, people that don't know exact value, because it's not related to mileage anymore. Mileage doesn't matter anymore with the electric vehicles. It matters how much energy you have left in your battery pack and how much your battery pack was wear over time. So
could you talk about this? Like, what does average battery wear look like? In other words, we know with like cars, they get to about 200,000 miles. Internal combustion, you're kind of done. You might get lucky and they go a little bit further. But like, what's a battery? After 100,000 miles, what's a battery look like?
The issue with batteries, it extremely depends by how do you drive the electric vehicles, how do you charge the electric vehicles, and where do you store the electric vehicles. So the answer is not really unique. It depends by, are you driving in Canada, or you're driving in South America or Miami? Are you extremely aggressive that every time there is a green light you push because you want to enjoy the acceleration? Of course, ludicrous mode and so on. So those are things that matters a lot on the batteries. And then there are also differences. Whether it's an engine, the engine right now is the ICE engine I'm referring to. They are more or less the same, identical, almost identical with each other. Battery packs are not. So even when they come out from the factory, they're not identical. They start from a slightly different health and so on.
And why is that? Why is that?
Because batteries are a live organism. It's very, it's not a simple mechanical aspect. There is electrochemistry behind. So we need to start to view batteries as a very complex things. And of course, the software can simplify and make sure that what the software does, make sure that all the batteries are similar to each other and more or less on par.
To guarantee that this vehicle will have the kind of performance than what its twin does.
Correct. Okay. But we do a step forward and we say, even if they're slightly different, the software layer will put them on a flat surface similar to each other, and then the way you drive it, the way you charge, where do you drive, we can still have an optimized control strategy for your own battery pack. And that's the paradigm that we want to bring to market. We call it EVI.
Okay, EVI. So you heard it here first, a battery is a living organism. So let's just give something for our audience, something practical. I think we know this. Let me just gut check with you. The proper care and feeding of your battery. You mentioned how you drive, where you drive. I assume if you live in a more temperate climate that doesn't have a huge temperature variation, your battery will likely last longer. Okay. Charging it, we've always heard, don't charge it all the way to 100%. Don't go to zero, like 5-10% to 80%. On a regular basis.
Is that true-ish?
So it depends by the chemistry. LFP can be 10 to 90, NMC can be 20 to 80%, but it doesn't make sense that the user optimize the charging, optimize the temperature, optimize how much they press. We need to have software layer that takes care of that. So the user just plug it in, don't think about it, and the software says, let me recharge up to 76% because I know that the day after you only need 20% charge. So the software can be unlimited, and that's why we are getting a lot of traction with different OEMs, tier 1 suppliers, and we are showcasing this solution. And actually, I can give you a preview since you asked about previews. We're going to have an in-vehicle demonstration, and we're going to show up at Move, a follow-up conference. We are here at CES, but the next one, Move, we're going to do a very big in-vehicle demo and driving from Turin to London with our couple of solutions installed and showcase great technologies.
In what cars?
Yes, what vehicles?
It's early. It's early.
Stellantis vehicles?
It's one of the most sold vehicle in the world.
It's a Corolla. No,
but it's electric.
Could be a Tesla. Could be a BYD. Yeah.
We'll circle back.
Yeah.
For sure.
Not a Maserati.
Who is
They're
your...
great.
Actually, related. Are you in a vehicle now? Is your technology in a vehicle that Johnny and I could go and drive today?
Not in production, but we have some pre-production vehicles that are testing our technologies and are getting great results.
And this is with Stellantis only, or with other partners?
No, also other OEMs as well. Yes, absolutely. We are not. I mean, definitely Stellantis is a very strong partners, and we are working with them. A great team, great innovators for sure. We're also working with others. And the goal of the mission of the company is deploy this tech to as many millions of people as possible, because it's working extremely well. It gives you an extremely accurate remaining mileage at every instances, so you know if you're gonna reach the grocery stop, or if you're gonna grocery shop, or if you're gonna be able to pick up your kid at school and so on. And it doesn't have. We have 1% error of the state of charge on the mileage remaining, extremely accurate. We have an extremely accuracy of the remaining useful life, how long my battery will last, 2 years, 3 years, 8 years, 10 years. Machine learning can actually predict that, and we have an extremely accurate remaining useful life algorithm, and also we can predict any potential failure, so the families are safer and
I'm predicting that you are going to be in the Ram electric truck.
Okay, that's a good guess. Maybe we'll meet up later on in 6 months.
Okay.
I was going to say, but this all sounds like, as someone who owns an electric vehicle, this sounds like stuff I'd like to know now. Is there any way, I'm not going to buy a new Stellantis tomorrow, but is there any way I could, get an app on my phone that my phone can talk to my battery? Is that possible at all, or you're not in deep enough?
Electra is trying to go to production with SOP start of production 2025. So we are talking with a couple of OEMs to get to production, of course.
But it has to be in the vehicle. In other words,
it needs to be.
You can't retrofit it.
It can also be retrofitted on the analytics aspect. I mentioned we do help with the design of the battery packs, analytics and controls. The design and the controls is more pre-production. The analytics can be even afterwards if you have the ability to connect your vehicle to our analytics platform. So
you technically could plug an existing EV into something, and the Electra software would say, here's this, here's that.
Yeah. About the app, yes, we could potentially launch an app in partnership with an OEM to show some of the highlights, your value of your battery. If it's going to value $10,000, $15,000, $20,000.
Well, the predictive failure, I think, is big, huge.
Well, this is. I was going to say,
that's got to be the killer app.
There's what's it? Is it called Recurrent? There's a process site, something out there that can tell you roughly the battery health. Do you buy into that?
That's an approach that is without machine learning AI. Basically, what you do, you hook up the battery and you discharge a couple of times, and you see more or less where the battery is at.
Right.
The machine learning doesn't need that, because it's gonna leverage the physics-based model, and it's gonna start leveraging the machine learning while you drive. So the accuracy is actually improving over time and not decreasing over time. So that's true. We can put and showcase a risk indicator and say your risk is going up and up and up. And maybe go to the mechanics or do something in your battery pack. So we can give these kind of alerts. Absolutely.
I'm going to suggest a line of business, which is if you can have a consumer-facing or even a B2B model that will tell used car sales of EVs to tell the buyer what the potential health of the battery is and how much value there is left in it. That's extremely valuable at this point. Everyone's like, the biggest knock of buying used EVs is like, oh man, when that battery fails, it's going to cost you $25,000 to replace.
Well, and then also,
and you have no idea what you're getting into.
Nowadays, a good year in the U.S., 15 million new cars are sold, but 45 million used cars are sold every year.
Yeah, and there's the Biden plan that are supporting the used car sales, used EV sales as well.
Yeah, but forget about the Biden plan. You look at EV adoption, it's just a line going up.
Yeah.
And so in 10 years, a lot of the used cars are going to be electric. And
let me know if you do that business. I'd be happy to help you with
that. Yeah. We can do a revenue split. You got it.
Yes. And I'd just like some cash because I was sitting here.
Okay.
Who is your competition?
Is there anybody out there that
So we do have a couple of companies. We are a scale-up companies. We are 55 people. We are growing. We raised $26 million in 3 rounds, and we are continuing to grow with our partners. We already generate revenue on the double digit and growing. We do have a couple of competitors in the US, in Europe, and in Asia, and so on. We have several competitive advantages, like this 360 degrees approach. It's very unique to us. We offer a full spread of solution like design, analytics, and controls. Others are only focusing on analytics or controls. Okay. And also we are agnostic to hardware and agnostic to chemistries. And that's something that was very hard to build in the algorithm. But now that we have it, every company is benefiting because basically they don't need 1 year, 2 years of having us adjusting the solution to a specific chemistries. They can come to us and in 2-4 weeks have seen already the benefits of that. Okay. So it's massive. And it's not only automotive. So Electra is now focusing on automotive, but think about we can apply this technology to robots. We can apply this technology to warehouse robots, drones, flying pods.
Yeah, anything with a battery.
Correct. Right. Anything with the battery.
Right. Okay. And then, again, just because I love your shirt. So AWS is your partnership in the cloud. BlackBerry, you work with InEVitable, the product?
Correct.
Which is their cloud software system too, right? Helps chat with AWS.
Correct. So we actually heard John Wall a couple of years ago speaking about this idea of on top of the operating system creating a middleware. That was basically the idea of to collect sensor data and create additional data sets, synthetic sensors. And we love the idea because what we do at Electra, we take inputs, and we talk about the 130 inputs, and we come up with insights. And as soon as we've seen the idea of InEVitable, even before calling it InEVitable, we said, okay, wow, that's exactly what we need. And we started to work with the BlackBerry team. We actually were the first investment of BlackBerry Ventures, and we started to build a partnership with them, very strong partnership. We've demonstrated several of our technology working with InEVitable, and now we are ready to production. So,
okay. And for those going back, John Wall is the head of BlackBerry QNX, which is basically the automotive platform, software platform, real-time operating system that BlackBerry has created. It's in a whole bunch of vehicles. And then Qualcomm also is a partner.
Well, we partner with chipset makers, and we have demonstrated our technology to be installed into NXP, Texas System, and Qualcomm, but it can be transferred to any chipset that a company like Stellantis, Volkswagen, Tesla, Rivian, and many others can utilize. So it's hardware agnostic.
Very smart. Right. That's what you use, hardware agnostic. Make as many friends as possible.
That's right.
Because it takes time. It takes more time. You need to write a code in a certain way. It takes longer time. Maybe it takes 1 or 2 years more. But once you have it, it's transferable. It's beautiful.
Right.
Do you have a position on, you said writing code takes so much time. Wouldn't it be so much easier if everybody using the same code and it was all open source, or no? Do you have any thoughts in that direction? There's a Red Hat, Linux, and GM. They're trying to go more open source. Is that...
The issue with open source is that you need... it's great for collaboration, and it helps innovation for sure, but the level of safety started to decrease because you basically need automotive certifications that are very time-consuming, very complicated, and we want to make sure that your software generated by a third party that you don't know where it is and so on is going to be certified.
ASIL-D, is that the one, right?
Well, ASIL-D is definitely a big one to do, but if it's an open source, who is going to pay for that? Who is going to cover that certification? That's why other operating systems are still not there yet. Maybe in the future, but it will take some time.
We're going to start wrapping up a little bit.
Yeah, I was going to say, I'm just, and again, I'm just always curious, and we're here, looking at future tech and what the future's going to look like. Right now, like a good electric vehicle, or it's like 300 miles of range, and the battery weighs 1,500 pounds or something. Like, what's the next generation of batteries? Like, what are we looking at? What do you see?
I think we're just at the beginning, because
if you look
if you look at the battery, every year we cut down 5-10% of weight by optimizing the chemistry, optimizing the architecture, and so on. So if you project this to 50 years, 100 years ahead, the battery pack will continue to get smaller and smaller, and maybe becomes as big as at this price.
There's got to be some sort of Moore's law, right?
Yeah, for sure. Yes, absolutely. But what I'm saying is that we're gonna see continuous increasing energy density, decreasing weight, and better performance. And of course, the software stack will make a big difference there. And we are gonna also start seeing firmware updates, similar to your iPhone or Samsung that receive an iOS update or Android update. We can do the same with your battery. So we're going to start to see firmware updates to improve over time.
This is already happening. I mean, you know, with Rivian, they did a vehicle update, but you went from having 314 miles of range to 328 via software update.
Right.
Hardware stayed the same. So it's already starting to happen.
It's happening.
So let me ask you, you said optimize the batteries. Do you have a viewpoint on what is optimum size and range? Like, I know there's a dependency on the charging infrastructure, but like I keep thinking about how first when after Tesla, some other manufacturers start coming, there's this whole range anxiety. Oh, how much is enough range? And I feel like the Germans, Porsche had the right idea, right? Taycan, it's only really 200 miles of range, but it's got super fast charging. It makes a lot of sense, but the dependency is this really crappy charging network in the U.S.,
and
right?
totally doesn't work at all.
Totally doesn't work, but it would in a future where we had more chargers, right?
It's still not enough range.
Do we need 600-mile batteries, or is it 300 that charge
600
charge to 100% in 5 minutes? Like, what do you think?
It really depends by the use case, how you drive the vehicle.
America. Impatient Americans. You've been here 15 years.
Something
like, come on.
Quickly.
Yeah.
We have a solution that actually understands how you drive the vehicle and how much juice you need for the day after. We call it the EVI Smart Charging. And we have seen that most of the time you just need the 20-25% the day after at maximum. So your battery could be less than half. So the cost could be lower. But it really depends by use case. So in theory, in a couple of years, we might reply to a questionnaire and say, where do you go? How long do you drive per day? And so on. Do you go over the weekend, long trips and so on? And after you answer, you have your ideal battery pack for a specific for your specific usage. So there is an optimal. There is no optimal solution. It really depends how you drive the vehicle.
He's a real agnostic. He's not committing to anything.
Okay. Well, let's talk about that because you're Italian. Now you've been here for 15 years, and you're so deep and very passionate about batteries. This is all counter to your national origin. Come on, what cars do you love cars? Do you have any gas cars?
Love cars.
Do you have any
I love motorcycles. I go to the MotoGP races anywhere around the world, and I actually ride the motorcycle as well.
Are you a Ducati guy? You like the doctor?
Ducati for sure. Of course, Valentino Rossi is an idol. A goat for sure. Yeah, no, it is amazing. And but I would say that I ride my bicycle in Boston, so I don't have the car and so on. Maybe when we're gonna have the vehicle in production.
What do you do in February in Boston? You're not riding a bicycle.
No, I ride bicycle even with a snowstorm.
You're a
but I'm waiting for have the EVI solution in a production vehicle, and then I get maybe 2 of those.
Okay.
Well.
Okay, great.
This was awesome.
This was fun. Too
Fabrizio
brief, but it's
Martini.
Nature of CES. Yeah.
Electric vehicles. Where can we find out more? This is great. He's got his hat.
Oh no! Show him the QR code.
There's a QR code. I'll hold up to the camera. You can take a picture of this.
No, hold your phone up to it.
And then hold your phone up to it. Electric vehicles.
Yeah. We have a LinkedIn, electravehicles.com website, also YouTube channel, electravehicles.com.
Great.
So check it out,
Awesome.
follow us.
Stellantis vehicles, I think I'm going to predict it'll be in the Ram Rev and maybe
Alfa Romeo, the next Giulia replacement.
Or that Charger.
He's Italian, the Giulia replacement.
Yeah, but what are they driving in this long-distance haul? And they says popular car.
Yeah, I don't know.
I would say write in the comments.
Oh, put your guess in the comments.
Right.
Anyways, Mr. Martini, thank you so much.
Absolutely, yeah, that was
really
great. Thank you very much.
Good chat.
Push for innovation.
Yes.
Yeah.
Well, that was amazing. This is this was 3 weeks ago we talked to this guy, and I've been thinking about my truck. There's an $18,000 battery in there, and I would love to know where it's at. What's the state of it? You know what I mean? And I think this is. Again, you have a virtual simulation of something you own running in the cloud, that they can give you information about, tell you to optimize it, or when you go to sell it, what it's worth.
Well, yeah, I wasn't kidding when I told him there's an entirely other line of business, I think, where he could just provide the service of evaluating the life left in people's batteries.
Check the Carfax, right?
Exactly.
Crazy.
That's exactly what needs to happen. So,
yeah.
Super interesting conversation
Not
on a topic
enough.
that I didn't ever think we would, never even broached my imagination. Similarly, the next one is going to be fascinating. I always thought Mobileye, and I kind of introduced this guy incorrectly. I always thought it was just like LiDAR, radar. It's actually vision systems, and it's basically...
It's so much more than
It's machine learning, and how do you make machines see the world, see the road ahead?
And by the way, your car you own right now, odds are high if you bought it recently, it's helping Mobileye to see the world.
Right.
Like currently, right now.
Yes.
It's crazy.
So you're going to talk to literally a professor, Shai Shalev-Shwartz, from Mobileye, subject matter expert on vision systems, including cameras, LiDAR, radar, as you will hear.
Professor Shai Shalev-Shwartz from Mobileye. Thank you so much for joining us here on the InEVitable. Very first question from me. I've always thought of Mobileye as they do LiDAR. Tell me, what is the best way to think about or describe Mobileye as a company? What do you guys do?
So we are. Let's look at it a bit from a bird eye view.
Okay.
If we look at cars for the last 20 years, many things has been changed. But maybe the most important two things in my mind are first safety.
Okay.
Cars are much safer today. Second, driving experience. So if you look at cars today, passive safety, active safety, it's really different than what happened 20 years ago. Also in terms of driving experience, maybe not 20 years ago, but 30 years ago, we were driving manual transmission.
Right.
Okay. Then came automatic transmission, ACC systems, automatic cruise control,
right,
lane keeping assist, and now more and more autonomy, what we call level 2+. So the driving experience is shifting from driving the car to supervising or monitoring what the automated system is doing.
Okay.
So Mobileye is doing things along these two lines. In terms of active safety systems, probably with a high probability, if you buy a car today, there is a Mobileye system inside.
Okay.
Responsible for alerting you for dangerous situations with a front-facing. Responsible for autonomous emergency braking sometimes. Okay. So the base of the technology is a front-facing camera.
Okay.
That looks at the scene, detect pedestrians, cars, lanes, and monitors the driver behavior. Okay, so that's on the safety side.
Okay.
On the driving experience side, systems like autonomous cruise control and lane keeping assist also relies on Mobileye technology in many of the cars. Not all of the cars, but in many of the cars. And now the next step for Mobileye is how you're going both with safety and with driving experience to the next level. Okay, and what we are doing is we are doing it in incremental way. So the next phase for us is called supervision system. Supervision system is surround sensing. We have 11 cameras around the car, and they can understand the entire environment around the car. And basically, similarly to Tesla FSD, these systems can drive everywhere.
With cameras.
With cameras alone.
Yeah.
Just camera vision, not radar, not LiDAR.
Not radar, not LiDAR. So of course, if there are radars, in some of the car models that relies on supervision, there is also a front radar. When it is there, we use it, but it is not a requirement. Okay?
Right.
The system can do everything just by cameras. Okay? What this system can do, it can basically drive itself everywhere. How we achieve it? Combination of perception, computer vision.
How do you see the world? Yeah.
Mapping. So we believe in whatever you can do offline, not online. Okay, we leverage the fact that many cars have our system for safety, the front camera. This camera, in any case, is in the car. It needs to detect lane marks, traffic signs, traffic lights for safety features.
Right.
So if all this work is already done, why not use it?
Right.
So what we are doing is we are uploading light information from the cars to cloud. The information is, here is a piece of lane mark. I saw a traffic light. I saw a traffic sign. Okay? And then we stitch all of the information together in the cloud to build a very accurate high-definition map. We call it REM,
Right.
Road Experience Memory. Okay? This is not just a HD map. It's also a mapping of how people are driving.
Right.
So if you are in Rome, you want to drive like a Roman.
right.
So we are collecting information on the typical speed that people are driving, whether they are driving in the speed limit or not.
So one of your colleague gave us an example, like there's a curve, and so the car might be capable of like maintaining 75 miles an hour around the curve, but to the occupants it would freak them out.
Yeah.
And then the car knows via REM that like, hey, everybody actually slows down to 55 around the corner. Do the same thing, even though the car's never been there.
Exactly.
Okay.
So when you are arriving to a new place, because you have REM, you are driving like a local.
Right.
Okay.
Right.
Even funny things like, there are these speed traps cameras. Okay. So we know to drive and then slow down like everybody else.
Right. Well, that like
It's
in Italy or Austria, it's being very handy
like
these days. Yeah.
it sounds a little bit like what Waze has been doing in the sharing of the information in real time. So does that mean that REM, there's a model in the cloud that is like a real-time map, high-definition map? So if
but with local knowledge.
if let's say 3 cars equipped with Mobileye technology and are going up to the REM, pass a point at this one right after another, they're literally updating. Like if a squirrel fell out, it jumped into the road, the first car caught it, the second car caught it crossing the road, and the third car hit it. That is all being logged.
And we actually think about it as a next gen of safety models, because if there is a hazard on the road, also for autonomous vehicles, but also for just manually driven cars, you can alert the driver in a much more effective way than just telling him that, like Waze are telling you that there is a stop car on the side.
Right.
But they don't have the accuracy of where exactly and how exactly it should affect you.
Right, because they have no sensors.
Yeah.
Right.
We have accuracy of 10 centimeters of everything that's happening. Okay, so we can tell you exactly.
Another thing, I was talking with one of your colleagues earlier, but for a long time now, since probably 2014, Tesla first, a lot of other people do this, but they have geofencing. So in other words, there's a speed bump by your house, and so instead of you having to manually raise your suspension every time, the car says, I know where I am, and it does it. But another Tesla never does it. Right, but so this is like cars equipped with Mobileye stuff that follow REM. They will know, hey, there's a speed bump there. Put the suspension up if that's what you need to do.
Exactly.
Right.
So, and also when we are driving with our system, our automated system, which is called supervision, then it knows in advance that there is a speed bump, and we know also in advance how the crowd is driving at this speed bump.
People
and
take
then
it
you
at
can
25.
say, okay,
Yeah.
And then you can say, okay, I want to be like the 20% low of the crowd, or 50% or 70%. So you can define as a driver how you want to compare yourself to other drivers.
Right.
Okay, so I like to arrive to speed bumps slowly. Okay, so I can do it relatively to what others are doing. Okay, so it opens a lot of options.
So one of the
real quick. Because I know you're Israeli and Waze is Israeli. Was there like mutual crossover between the two companies?
No, not really. But great mind things alike.
Okay. Well, I'm glad you guys. I was going to ask a Waze question. I'm a huge fan of Waze. We adopted them at MotorTrend very early on, and the technology I still use it to this day. One of the most powerful things they did in terms of demonstrating
the mapping, because they had the most accurate and up-to-date maps because of people who were using it, right? And they would show this. I think they showed the 24-hour map of Paris, and you could see the peak of the day, all these people, and redrawing the map. Does something like that exist at Mobileye, where you can, as the day starts, you can start to see the usage and this cloud, this data, whatever set grow and populate, and it'd be a very interesting visual to see, right?
So yeah, it's of course possible, but we are building it with layers, and the most important layer for the start, which is complicated enough, is just understanding really to 10 centimeter accuracy everything that is needed for an automated system in the car. But of course, these ideas are up and running, and it depends on collaboration that we are doing with OEMs, traffic information. What else can we extract from this asset? Because it's a great asset.
Now, with REM, you're using camera data, but I know you guys also use radar and LiDAR and other systems you make. Is radar and LiDAR information fed into REM, or is it just camera?
So no cameras at all. What we upload to the cloud is processed information from the camera.
Yeah, I'm sorry, process information from radar and LiDAR. Does that go up as well?
Yeah.
Why not? Okay.
Why not? I mean, if the car has other sensors, okay, what we upload to the car is our understanding, this car understanding of the surrounding.
Right.
And the idea is that understanding of the surrounding is very, very accurate in the close range. The real problem is what happens in the far range.
Do you take any, just real quick, do you take any data from the car itself? In other words, probably take vehicle speed, but like ambient temperature or, I don't know, what, tire pressure or anything like that, that might be relevant?
Yeah, it is relevant actually, because the tire pressure, for example, is relevant because if you look at how cars are actually calculating speed, it depends on the car pressure.
Yes, okay.
And speed is very important because in order to understand to 10 centimeters accuracy what we read from the car, we want to do what is called ego motion. So understand how the car is moving relatively to the ego. And for that, you need very, very accurate speed. So everything is connected. And the nice thing is that it's not something that we are doing for the mapping. We're doing it anyway for the safety system that is on the car.
Right.
So if we are anyway doing it, why not piggybacking on this information and just upload the card and then everybody can enjoy it. Another thing which is very interesting in here is what we call semantic information. So, for example, who has a priority in some intersection?
Right.
Okay?
We talked a little bit about, yes, this is interesting.
So if you just look at the traditional way to construct high-definition maps, then someone needs to figure out the priority. It's not something that, even if you have a LiDAR on the roof, it doesn't tell you who has priority. So either you need to read traffic signs and have some logic on how you set priority, okay, or manually label the priority, but then you have human errors. In REM, we can look not only on the legal priority, but also how
Customs.
the crowd interprets this priority.
Right. So in Rome, everybody hits each other.
Yeah, I mean, look at some examples. So when you are merging into the highway, okay, in some countries, so there is a priority there. The guy on the highway has a priority over the guy that is merging, okay?
Except for in Miami.
Yeah, so in some places, so you just ignore the priority and fit in.
Yeah.
In some places, people when they are arriving to emerge from the highway, they are performing a lane change, okay, in order to be polite for the people that are fitting in.
Yeah.
So really, you want to understand the culture.
Yes.
Okay.
Right.
Yes.
And this approach helps you understand the culture of driving.
Okay.
Right.
I'd love to see your Moscow map. I'd love it.
Or these the train those intersections in like Vietnam. Vietnam with all the scooters and everybody.
Right.
Okay, so because I'm conscious we're running out of time, we in your booth you have two vehicles on display. You have a Polestar, and then you have a
Polestar 4.
Polestar 4, and you have an VW ID Buzz, which you don't get yet in America. And they're
we don't get the 4 either.
The Buzz has a bunch of really cool, bulges and plates and things on the roof, more than just cameras. So what's that all about? What else do you guys do?
So it's all about how you reach autonomy. And there are 2 paths, okay? And it's important to understand that they are really different. One path is start from bottom up, okay? So start from front-facing cameras and have ACC, LKA, stuff like that.
Adaptive cruise control, lane keep assist. Yes.
Yeah.
Okay,
and then go to supervision system. It's our next gen, which has cameras all around, and it can drive itself everywhere. But it's not. It's we call it a hands-off, eyes-on system, because the human driver still needs to supervise the system. It's not good enough in order to drive itself, and you can.
Camera base is not good enough for full self-driving, shall we say?
Exactly.
Level 5. It's not good enough for level 5.
It's not enough even for level 3. Okay.
It's not enough. I like this.
Okay, I will.
Thank you. I like this a lot.
So how you go up?
And real quick, just level 3 in the U.S. at least means that Polestar assumes the legal liability for what the car is doing, not the person behind the wheel.
Yeah.
So just by having just vision, Tesla, it's not good enough to assume legal liability.
But let me not talk about liability. Instead, talk about what we as a society, because liability is the aftermath. Okay.
Oh, I agree.
I want to say, okay, we need to be responsible. Okay. What is a responsible thing to do?
You're saying it's the ethical thing to do.
It's an ethical thing to do. You don't want to put a car which is not we call it MTBF, mean time between failure. Okay, so the mean time between failure of a system, in order to be automated and eyes off, it should be superhuman. If it's superhuman, okay, we can discuss how much we want more than superhuman. But if it's not superhuman, for sure, it cannot be eyes off.
Okay.
Period.
And
we don't want machines that are worse than humans to drive by themselves.
So to be superhuman, you need a combination of cameras, radar, and LiDAR?
In our opinion,
yes.
In our opinion, yes. And let me explain why.
Yes.
But maybe before I dive into it, just going back to the Polestar versus iBuzz. So bottom up is front-facing, then supervision, cameras only. Then you add sensors for redundancy, and you can go eyes off. And gradually you expand what we call the ODD, operational design domain. So initially maybe only on highways you can be eyes off. And maybe and then more roads and more roads. But this is a consumer cars that gets more and more automated systems. Okay? The other directions, let's call it top-down, is robotaxi, in which you say, okay, I want level 4 from day 1. Okay? No driver in the car. Okay? And then you say, okay, but it's a very, very difficult problem. So I need many sensors. Okay? Again, we want to be superhuman. And maybe I want to be geofenced. Maybe I want to start only with one city, and even in this city, only one geofenced area.
Right. So
we've
mastered like the east side of a town.
Or parts of Austin.
Exactly.
Exactly.
So these are 2 directions how to reach automation. Eventually, they will merge. Okay. But do you want from here or from there? Tesla are maybe the louder company that talks from bottom up. Waymo is maybe the louder company that talks about top down. Okay, in Mobileye, we honestly, when we started developing, we didn't know how the future is going to look like. There were good arguments that it's going to be top down, good arguments that it's going to be bottom up.
It would be cheaper if it was just camera.
Yeah,
from a hardware point of view.
You essentially support both.
And then what we said the essence of the technology, we build it in a way that it supports both. Okay. So let's do both. Let's hedge. Let's do both directions. Now, why is it very, very different from, for example, the approach that Waymo took? Waymo took a LiDAR-centric approach. So for doing the top-down, they started from, we require a very, very strong LiDAR, okay? And then you cannot do both, because there will be no strong LiDAR for consumer cars. It's too expensive, okay? But our approach, even for the top-down, was that, first of all, you need camera-centric approach. Roads are built for humans, and humans have eyes, no LiDARs. Okay? So the major sensor should be cameras. Okay? But It's not enough. So build the system for cameras, okay? And then add layers of redundancy in order to reach the high MTBF that is required to be superhuman. So since we are doing it, we can do both bottom up and top down with the same technology.
Let's fill in the blanks for the audience who's like, well, why? Yes. Why can't it? What does LiDAR and radar do that cameras cannot? Why do you need that? And I know some of it's weather, like seeing in the dark, all this kind of stuff. So what are the advantages of those systems?
So I don't want to say that they can do things that camera can't do, because you can drive with only your eyes and you can drive in all conditions. So
okay, very good.
This is not my point. My point is that these are different sensors, and in what ways they are different. Cameras, by and large, okay, is a passive sensor, not an active sensor. Passive sensor means that there is no source of light. We use another source of light, either the sun, if it's in the day, or the headlights, okay, if it's at night. Okay, unlike radar and LiDAR, they are active sensor, meaning that they are shooting some signal, okay, getting back the returns from the signal, and based on them understand something. So this is the first difference between these sensors. The second difference is that camera is a very high resolution sensor relatively to radar and LiDAR. So camera, today technologies of camera is much higher resolution than LiDARs and radars, meaning that you can understand semantic information which you can't understand from radar and LiDAR. So for example, you can't read a traffic sign by LiDAR.
Right.
Okay?
And LiDAR, there's like 150 lines of resolution, whereas with cameras now it's in the billions. 1,000. Okay. Yeah. So
millions of pixels.
Yeah. Okay. So it's much better.
Yeah.
So this is the second difference. Okay. The third difference is that cameras are 2D sensors, while radars and LiDARs are 3D sensors. What does it mean? The raw signal of radars and LiDARs is a point in the 3D world. Okay. On the other hand, in camera, what we really see is a projection of this point on a 2D space. So we see part of the information, not all the information. And this is some of the reason that we have hallucination in cameras.
Right.
Okay, is because I can show you a video of a car in a flood, and then I will zoom out and you see that it's a toy car in a small pond. Okay.
Right. And so for instance, for like high speed, LiDAR is good because it can see 500 meters down the road, and it knows the dimensionality. It knows something's coming 500 meters away.
Well,
whereas a
cameras can see also 500 meters away. It's a matter of resolution, and most LiDARs can't see 500 meters away. So it's not just a matter of range. Okay. It's a matter of the type of signal that you are getting.
Okay.
In LiDAR, you are getting, I know that something is 200 meters away at an accuracy of 10 centimeters. In camera, what you see is a reflection or a projection of it on the 2D.
Yeah, that's more what I meant. Yeah. So
yeah.
Okay, yeah.
And then the difficult part in camera is, since the control of the car is done in the 3D world, you need to lift back the information from the 2D to the 3D, which is very difficult.
It's a lot of processing.
Exactly. Yeah. This is why it requires a lot of processing.
So if you have 3D sensors, then it doesn't require as much processing because it's already in the 3D language.
Exactly.
Okay.
So who is better? Which sensor is better?
Right.
My point is,
all of them.
All of them has problems. All of them has disadvantages.
Right.
All of them have advantages.
Right.
So the game shouldn't be, this is the ultimate sensor. Likewise, which algorithm is the best? So you can hear some players are saying, okay, we want end-to-end algorithms, the AI will figure everything. And other players are saying, no, we want a decomposable approach, we want to do it in parts. What we are saying is, again, every method has advantages and disadvantages. Don't be religious about methods, okay? You want as many as you can. Build redundancy, okay? And this is how you can reach 99.9999% the MTBF, which is required in order to let the driver eyes off the road, okay? So just set the bar, and do whatever you can in order to reach it.
Okay, this is great because you're giving me the jumping off point for the next question, which is, okay, so now I'm pretty clear. Mobileye can provide a range of solutions, inclusive of camera systems, vision, the radar, lidar. You build the chips, you build the camera systems. You support all these manufacturers on the road towards potentially full autonomous driving. There's been a lot of hiccups in autonomous, right? We saw some very well publicized things happen in the last 18 months or so. Argo AI went kaput. Cruise had that huge incident. I'm curious. Well, I'll just get to because we're running out of time. We'll get to the core question, but I want to back out later and ask you just for your overall sense of where we're going, how fast autonomous is going to get here, what do you think about it? But what's your position on human in the loop? You talked about eyes off. I saw some great demos in your booth of some cool things that the car's doing. It moves out of the way from a semi-truck. I follow a critic in this space, Dr. Missy Cummings. She was formerly of the Biden administration, and NHTSA DOT, and she's been very critical of the way a lot of these autonomous leading companies are in their approach. And one of her main arguments is that when you have a human in the passenger seat and they're supposed to basically take over when this superhuman system is not so super, like that's bad. Like these systems are essentially training people to not engage, and the reaction time for them to come off of whatever they were doing,
wake up, get off their phone, whatever.
Yes, creates a real problem. And I'm probably butchering that, in paraphrasing it. But where do you sit on this? What's Mobileye's position?
So, it's a very good point. And Mobileye position is, again, we have the bottom up and the top down. Okay. In the top down, we can talk maybe later about safety and about exactly what does it mean, because I think it's very important to also crystallize what does it mean by safety.
Yes, exactly.
Okay?
Safety for who?
Safety for who?
Yeah.
Exactly.
Yeah.
In the bottom up, in the consumer cars, okay, yes, there is an issue, and our approach is that we must be in a position where human plus machine is better than human alone and is better than machine alone. We don't want to be in a position that we put a semi-automated system and end up with a system which is worse than human alone. Okay, we want to be better. Okay, and part of the approach to tackle this is from day one in supervision system, there is a driver monitoring system. So if the system is not good enough to allow driver to be eyes off the road, we must verify that eyes are on the road, and not rely on sensors that detect if he puts hands on the wheel, because then he will put something on the wheel or will cheat.
Actually, my trick is I lower it down onto my knee, and that can't tell a hand from a knee.
Yeah.
Oh, sorry.
So we want a driver monitoring system that will make sure that your eyes on the road. On one hand, we don't want to annoy the driver and tell them every 20 seconds that it's just annoying and it's not helpful. We want it to be helpful, and in order to be helpful, you want a driver monitoring system, and this is part of supervision. So in any step that we are doing, we have the mantra of we want that the combination of machine plus human will be better than human. Okay. And we think that there are many opportunities here in the fact that you have a strong computer that looks 360 around the car, opens up many opportunities for higher safety. So if I go back to what I started by the two things that shaped car industry in the last 20 years, safety and driver experience, we want that supervision will help both. It will help safety because the fact that you have 360, the fact that you have road experience memories and mapping, okay, that alerts you on potential hazards, makes the system safer than those that only has front-facing camera. And on the other hand, we want to improve the driver experience.
So isn't the argument that until the system of machine plus human is better than human, the fail-safe shouldn't be a human, and you should take it out until you have a system that is 100% of the time not reliant on a human, overseer?
so again, so we need to look at statistics and see if the human plus machine is better than human or not. If it's not better than human, then yeah, you're right. We need to wait with this approach. Okay. But if it's better than human, then we should go for it because it's better.
And we're seeing that with automatic emergency braking.
Exactly.
Is especially in the age of, while you're
Everybody-
driving,
yeah, okay.
that it is safer.
Okay.
Yeah.
All right.
Oh.
We're almost out of time. How do you see the autonomous world? Given all these sort of recent setbacks, our Cruise got their permit pulled. At the same time, Mercedes got level 3 driving
In
certification
California,
in the
Nevada.
U.S.
No, California, Nevada.
California, Nevada. Where are we? How are we? Are we on
What
schedule?
year does the steering wheel leave the car?
Yeah, all the bigger picture questions. And is this like a blip in the roadmap, or just hey?
So the way I see it, first I think that this is not the right question.
Huh?
Okay.
All right.
I love
So the right question is not when the steering wheel out of the car. The right question is when do you see jump in the driver experience and safety of your car? When your car as a consumer will be totally different than what it is today. And I think it is happening now, and it is happening fast, and you will see it in the coming 3 to 4 years in a massive amount of cars. And what the revolutions that I see? 2 revolutions. First, level 3 systems which are really useful, and I don't want to say who is not useful, but level 3 systems that can really take the driving in the boring elements like highways and traffic jams up to 130 kph, not just very, very slow driving, okay?
80 miles an hour.
Yeah,
Yeah.
80 miles per hour.
Sorry, we Americans. Go ahead.
Yeah. So this is coming. Mobileye has design wins on these cars. They are coming, okay? When you buy such a car and you can have eyes off on the road, not everywhere, not in urban roads, but in highways roads and in traffic jams,
Sure.
you will see a huge jump in driver experience. So this is one thing that will change your life, okay? You can buy back your time,
Right.
okay?
Yeah. Or waste it on social media. Either way. Go ahead.
Right. However you like.
Yeah. The other stream which I think is important is what we call Vision Zero. What is Vision Zero? So the Sweden Parliament had a decision in 1997
Yes.
to reach a state where there are 0 fatalities from
Yes.
car accidents.
Yes.
Okay, and the idea was that you should design roads in a robust manner that will be tolerant to human mistakes.
Yeah.
I think the same will happen now with supervision and systems like this, that they can bring levels of safety, which I will not say 0, but they will give a huge jump in safety. We want to decrease significantly the amount of people that are being hurt or die from
Which is
car
a massive
accidents.
number. When you actually read the global, I mean, in the U.S. we're back up to over 40,000 deaths per year, but globally it's way higher. I mean, some of that's poverty related, a lot of things like that. But
So I think there is an opportunity here, and I think that 2 to 5 years from now, so we already have these systems in a small number. The big jump is coming in the coming 2 years. I think that in 5 years we will also have in big numbers eyes-off systems. And then if we look back in 5 years from now on today's interview, we will see a jump in safety and a jump in driving experience. Cars will look very, very different.
Yeah.
Okay, so I think it's coming. We talked about bottom-up and top-down, okay? I talked about the revolution that is coming from bottom-up. I still don't know the top-down part. The main issue there is not technological, is more a business side of the things.
Legality.
Because it's so expensive.
It's expensive, and can it be a viable business?
Interesting.
Okay.
All right. This is great, and I love that you put us on the clock for 5 years. So we'll definitely chat with you. I hope sooner than 5 years.
Yeah.
My last questions. 2 questions are: what do you drive? Okay, 2, and then, and this is a feel free to brag a little bit, or what can our listeners or people watching this? What is the best experience that they can have in an advanced ADAS or semi-autonomous driving system today or maybe this year coming out? Is there a vehicle,
Is there a car on
a
sale
model
right now that you're
that you
a lot of
support,
Mobileye technology that you're proud of?
that you support? Which one is it? What would be the best case if someone's like, man, I want to experience what this guy's talking about?
So I'm driving today. The car that I'm driving is a Zeekr car.
Okay.
It's the first system that came with Mobileye supervision system.
Okay.
And I can
Zeekr's
tell you,
a Chinese
Zeekr's,
company.
it's Geely.
it's part of Geely Group,
right.
and it's a great car, and I love it, and especially it takes me from point to point. Okay, so I enter the car, I put an address, it drives there.
Is this the van? Is this like the
No,
van?
it's not a van. It's how do you call it? In
Compact car? Small? Yeah.
SUV?
It's not an SUV exactly.
Hatchback?
Yeah, something.
Shooting brake.
Shooting brake.
Station wagon.
Okay, station wagon.
Okay.
Okay.
Yeah.
So, so this is a car that I'm riding, and I'm using it. All the time put new versions on it in order. I test it myself. So I believe in hands-on. I code myself and I test the car myself.
Oh wow. Okay.
Okay. And for fun, I ride motorcycles.
Oh.
But that's
Okay.
So the opposite. No safety
safety.
whatsoever.
That's great.
Yeah. Okay.
But
okay.
now to
What kind of motorcycle do you ride?
I'm riding a Honda.
Okay.
But
which one? Which Honda?
the 750 NC700.
Oh, big one. Okay.
Yeah.
Okay.
Right. Nice.
So regarding car experience and what will be different in the coming years. So Polestar, I wish that you could experience the Zeekr, but it's not coming to US soon. It's coming to Europe, by the way. Polestar will have, again, the supervision system.
So we're gonna get, we'll get Polestars, Volvos, and Lotus. So the big Lotus
Yeah.
SUV.
And these are based on IQ5. The next gen, IQ6, will be a big jump. And we announced on, design wins for the IQ6. It will be a big jump. We measure jumps by MTBF, but by mean time between failures. And we are getting to point where, most of the time you don't need to interfere with the car. Okay?
Right.
But the highest jump will be when we will have eyes-off systems. And this is coming start of production end of 2026. So 2027, I think this will be the big jump. That if you can buy a car and you can drive on the highway and traffic jams without looking at the road, this will really be a revolution.
What's the current state of the art for MTB? What's a good number?
So MTBF, mean time between failure.
Yeah.
So to give you some statistics, currently, we are around 50 hours. Okay, so meaning that you can drive 50 hours without intervention. Okay, and this was done not by us. It was done by people that evaluated.
So that's a lot different than my experience, which 50 seconds would be a very high number. So
yeah, but this also depends on the ODD. It depends where you are driving. Okay.
No, I'm just saying with every car I've driven a lot of level 2 stuff, a lot of, I know like Tesla and Volvo, they don't even like to use the levels, but it's always failing.
Yeah. But still, it sounds good.
Yeah.
But it's horrible in terms of you cannot let eyes off.
Right, and you don't want any failure.
Yeah.
Right.
Yeah.
Yeah.
The roadmap is that these systems will go to. So for eyes off, we're talking about millions or 10 millions of hours.
Wow.
MTBF.
Wow.
Otherwise,
how do you even measure? So that's collectively. In other words, you have a fleet of vehicles, and every million hours driven, there's one failure.
Exactly.
Okay. Wow. Okay.
Exactly. Which is better than human statistics.
Yeah.
And this is where we want to be.
Sure.
We want to be better than human statistics.
Sure.
Okay.
And then overall, you reduce number of car accidents.
Right.
Okay.
Right.
All right. Well, we'll have to leave it at that.
Wow, Professor, that was very enlightening.
Very
good.
Yes. Thank you so much for your time.
Thank you for hosting me.
Yes, and we would love to check in with you on the road to the next 5 years. Maybe we'll come and chat once.
And I used to work with your man over there, so we know each other pretty well.
So, but yeah, we appreciate the time. Best of luck.
Yeah.
And thank you so much for being on the InEVitable.
Thank you very much.